Hello students, welcome to my class. Today we will continue with the chapter Trigonometric Functions of class 11. In my previous video we have already seen trigonometric ratios as functions and the signs of trigonometric ratios in different quadrant. Today we are going to see the domain, range and graph of trigonometric functions. So we will see one by one. So the first function is f of x is equal to sin x. First trigonometric function is f of x is equal to sin x. So we are going to see what is the domain, range and graph of sin x. So here if you see what do you mean by domain actually? Domain is values of x for which the function is defined. So here if you see whatever value you take for x, for example if I am taking x is equal to 0, f of x is equal to sin x, that is sin 0 is equal to 0. If I am taking x is equal to pi by 2, therefore f of x is equal to sin pi by 2 which is equal to 1. If I am taking negative angle, if x is equal to minus pi by 2, then f of x is equal to sin minus pi by 2 which is equal to minus 1. So whatever value you are taking for x, whatever angles you are taking for x, for all these angles the function is defined. We are getting a unique f of x. So for every value of x the function f of x is defined. So we can say that the domain of the function sin x is the real number, set of all real numbers. So here we can write sin x is defined for all values of x. Therefore, domain is equal to, so domain of sin x is equal to set of all real numbers. Now we will see what is the range. So range is the value of the function, value of f of x is range. So we will see that. So let us consider the unit circle with origin as its a center. So let us consider the same unit circle which we have already discussed in the previous video. So the unit circle we will consider with the origin as the center. So this point is the origin. Now you know that what are the coordinates? These points A, B, C and D. The coordinates of these points we have already discussed. So this point is 1, 0 and here it is 0, 1 and for this point the coordinate of C is minus 1, 0 and the coordinate of D is 0, minus 1. We know the coordinate of this point because since it is a unit circle, the radius is 1 unit. So we will get the coordinates of the point A, B, C, D. Now if you consider a point P, A, B on the circle and suppose if this point P makes an angle x radian with the positive direction of x axis, you know that how will you represent the coordinate of P, that is cos x, sin x. The coordinates of the point P is cos x, sin x. So here if you see, if I am drawing a perpendicular PM to the line OX, then this sin x is nothing but the height of this triangle, that is this PM value is sin x. So if I am taking, if we increase or decrease the value of x, suppose if I am decreasing the value of x, imagine if I am decreasing this value of x, then what happens to the height of this triangle? It is decreasing. When it becomes 0, when the angle is become 0, then here the sin value, there is no triangle and there is no height. So at this point the sin value is 0. Similarly, if you increase the value of x, if I am increasing, I am taking another point Q. So here the angle is x is more, angle of x is increasing. In this case the height of the triangle is increasing. So in the first quadrant sin x can take the value from 0 to maximum is 1. So sin x can take x. So you just see the y coordinate of these points. From that we will get the range of sin x. So in the first quadrant, if you see this point here, the y coordinate is 0, and for the point B the y coordinate is 1. Actually sin x is nothing but the y coordinate of the point. So in the first quadrant, sin x value ranges from 0 to 1. What will happen in the second quadrant? If you see in the second quadrant, sin x value, if the angle is increasing, sin x value is decreasing here, that is from 1 to 0. So in the second quadrant, sin x is decreasing from 1 to 0. And what about in third quadrant? Again, if you see, it started increasing in the third quadrant. The value of sin x is decreasing from 0 to minus 1. Again in the fourth quadrant, from minus 1 to 0. So what is the value of sin x? From this diagram it is very clear that sin x value always less between minus 1 and plus 1. So we can write minus 1 less than or equal to sin x less than or equal to 1. So the range of sine trigonometric function, range of this is equal to closed interval minus 1 plus 1. So we got domain and range. Now we are going to draw the graph of sin x. So that is very important, graph of sine function. So for that, first we will draw the x-axis. In x-axis we will denote the angles. So 0, here pi by 2, pi, 3 pi by 2, 2 pi, and this side we will mark the negative angle, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Now if you see here, for when x is equal to 0, and here y-axis, we will draw y-axis also, and y-axis, this is y and y dash, here we will mark 1, and here the point minus 1. Now you see here, when x is equal to 0, what is the value of sine? So sine 0 is 0. So at this point, when angle is 0 degree, sine value is 0. So this is the point. Now you already know that when sine values are zeros, you know. So sine values are 0 for all the integral multiples of pi. Sine value is 0. Already this we have studied. Sine x is equal to 0 for x is equal to n pi, where n belongs to z. For all integral multiples of pi, sine value is 0. So for all these points, sine x is 0. Now the remaining points we will see, when x is equal to pi by 2, then sine pi by 2 is equal to 1. So here the value of x is equal, sine x is equal to 1. Now what about then 3 pi by 2? When x is equal to 3 pi by 2. When x is equal to 3 pi by 2, sine 3 pi by 2 is equal to, so here the answer is minus 1. So when x is equal to 3 pi by 2, sine 3 pi by 2 value is minus 1. So here you will get minus 1. You have to mark minus 1. Similarly, we will see the negative angle also. For negative angle, we will calculate sine value. For x is equal to minus pi by 2, sine minus pi by 2. So sine minus pi by 2 is minus 1. So for minus pi by 2, here sine value is minus 1. For minus pi by 2, sine value is minus 1. For minus pi, sine value is 0. Again for minus 3 pi by 2, when x is equal to minus 3 pi by 2, sine of minus 3 pi by 2 is equal to 1. Actually this value is 1. So you have to find all the values of sin x at these angles. At least for these angles, if you are able to find out sine values, then you can plot all these points. You can join these points using curve. That will be the graph of sin x. So listen here. So this is the graph of sin x. Okay. So this is how you have to draw the graph of sin x. You know that all the multiples of pi, integral multiples of pi, you can mark as 0, and for the other angles, you find out sine value, plot that point, you will get the value of, you will get the graph of sin x. Now the next function we will see second function, that is cos x. Now second function, that is f of x is equal to cos x. Now we are going to see what is the domain, range and graph of cos x. So for cos x also the same way, whenever we are taking, when you want to find the domain of cos x, you have to find all the values of x for which the function is defined. So we will just take few angles. So when x is equal to 0, cos 0 is 1. When x is equal to pi by 2, cos pi by 2 is equal to 0. When x is equal to minus pi by 2, that is cos minus pi by 2 is equal to 0. When x is equal to pi, cos pi is equal to minus 1. So even if you are taking negative value or positive value, negative angle or positive angle for x, cos x is defined on that points. That is, cos x is defined for all values of x. Therefore, domain of cos x is equal to set of all real numbers. So the domain of cos x is also same only, set of all real numbers. And another thing, the range, we will move on to the range now. What is the value of cos x? Cos x always lies between the same, similar to sine function. Cos x always lies between minus 1 and plus 1. So even in the same diagram, the unit circle, if you consider and you check, you will have this only. The cos x value lies between minus 1 and plus 1. Therefore, range is equal to closed interval minus 1 plus 1. Now we are going to draw the graph of cos x. X dash. Here we will mark y dash, y. This point is 1 and this is minus 1. 0, pi by 2, pi, 3 pi by 2, 2 pi, and here minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Okay, so when cos function is 0, when you will have cos x is equal to 0, this we have already studied. Cos x equal to 0 for all odd multiples of pi by 2. So for all odd multiples of pi by 2, cos value is 0. That is, for pi by 2 this is 0, and for 3 pi by 2 cos x is 0, and similarly minus pi by 2 and minus 3 pi by 2 cos x values are 0. So at these angles you can mark on the x-axis. These angles you can mark in the x-axis. Now for the other angle we will find out now. What is for cos 0? When x is equal to 0, what is cos 0 value? When x equal to 0, cos 0 value is 1. So x equal to 0, cos value is 1. Now when x is equal to pi, cos pi is minus 1. Cos pi is minus 1. Okay. Now when x is equal to, when x is equal to 2 pi, cos 2 pi is equal to 1. Cos 2 pi is 1. And similarly here, when x is equal to minus pi, so cos minus pi is minus 1 only. So cos minus pi is minus 1. So here we will mark. And again, when x is equal to minus 2 pi, cos of minus 2 pi is equal to 1. So here cos of minus 2 pi is equal to 1. So now we will plot all these points. not plot, we will join all these points. We will join all these points, and this is the graph of cos x. Okay, so this is how you have to draw the graph of cos x. Now we will see the next function, tan x. Now the third function, f of x is equal to tan x. So tan x we can define as sin x by cos x. We know that tan x is sin x by cos x, but here the denominator should not be 0. That is, the condition is cos x should not be 0. But when cos x will be 0 for all the odd multiple of pi by 2, cos x is 0. So x should not be. So this condition we can write as x should not be odd multiple of pi by 2. So this is the condition. This is the function tan x. Now we will see the domain, range and graph of tan x. So domain means all the values of r we can take for x except this odd multiple of pi by 2. So domain is equal to set of all x such that x belongs to r and x not equal to 2n plus 1 into pi by 2 where n belongs to z. So this is the domain of tan x. Okay. Now we will see the range and the graph. Before going to range, we will draw first graph. So x dash x and here 0, y dash, here we have 0, pi by 2, pi, 3 pi by 2, 2 pi, here we will have minus pi by 2, minus pi, minus 3 pi by 2 and minus 2 pi. So now you listen here, before drawing the graph of tan x, at odd multiples of pi by 2 the function is not defined. That is, at the angle pi by 2 and 3 pi by 2 the function is not defined. So at this point we will draw this dotted line, because at these points the function is not defined. For odd multiple of pi by 2 function is not defined. So we will draw like this. Now for these angles we will see what is the value of tan theta. Okay. So when x is equal to 0, tan 0. So tan 0 is sin 0 by cos 0. Sin 0 by cos 0. Sin 0 is 0. Cos 0 is 1. So the answer is 0. So for x is equal to 0, tan value is also 0. So this is the point. Okay. Now when x is equal to pi, then tan pi is equal to sin pi by cos pi. So you know that sin pi is 0 for all the integral multiples of pi. Sin value is 0 and cos value is minus 1. So this is also 0. So for these points the tan is 0 only. These points the tan value is 0 only. Now you see here, when x tends to pi by 2. Suppose if x tends to pi by 2, what is the value of tan? So tan x tends to. So tan x is equal to sin pi by 2 by cos pi by 2. So what is the value of sin pi by 2? 1. So 1 by 0, which is equal to infinity. So when x tends to pi by 2, tan x tends to infinity. So how you will draw the graph? You have to draw like this. When x is equal to 0, tan value is 0. When x tends to pi by 2, tan x tends to infinity. So we will draw like this. It should not touch with this dotted line. Okay, it will go very close to this, but it will not touch with this dotted line, because when x tends to pi by 2, tan x tends to infinity. Now what about then minus pi by 2? When x tends to minus pi by 2, so tan x tends to sin minus pi by 2 by cos minus pi by 2. that is minus 1 by 0 equal to minus infinity. You will get in the downward direction. That is, when x tends to minus 1 by 2, tan x tends to minus infinity. So this is minus infinity and plus infinity. Now you see here, tan value can take, tan x can take values from minus infinity to plus infinity. So the range will be r. So here the range is from minus infinity to plus infinity. So the range of tan x is r. Now the remaining angles, how we will draw the graph? Same way. When x tends to 3 pi by 2, this will go to tan x tends to infinity, and here you will have a minus infinity. Same way from this point also it will go to infinity, and from here it is minus infinity. So this is the graph of tan x. So the domain of tan x and range of tan x and the graph, we have seen these three. Now we will go to the next function, cot x. Now the fourth function, f of x is equal to cot x. So here cot x we can define as cos x by sin x, and here the sin x denominator is sin x. So sin x should not be 0. That is the condition, sin x should not be 0. So when sin x will become 0 for all the integral multiples of pi, sin x will be 0. So x should not take n pi, that is integral multiples of pi. So the domain of this function cot x we are going to write, we can take, x can take all the values of r except integral multiple of pi, where n belongs to z. So this is the domain of cot x. So this denominator cannot be 0. So x should not be integral multiple of pi. So except this angle, all other values of real number x can take. At this point the function is defined also. So the domain is set of all x such that x belongs to r and x should not be equal to n pi, where n belongs to z. Now we will see the range and the graph of the function cot x. Okay, so this is x dash, here we will have y dash 0, pi by 2, pi, 3 pi by 2, 2 pi, and here we will have minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Now you see here, at this point, that is the integral multiple of pi, the function is not defined. That is at which angle? This angle pi, at angle pi and angle 2 pi, and the negative of this angle, that is minus pi and minus 2 pi. So at this angle, at these points the function is not defined. So we will see what about the other angles. Okay, so when x is equal to 0, what is cot x? Cot x is equal to cos 0 by sin 0. That is, cot x is 1, so 1 by 0 is equal to infinity. So when x is equal to 0, cot x is equal to infinity. When x tends to 0, cot x is infinity. Now at this point we will see, when x is equal to pi by 2, when x is equal to pi by 2, cot x is equal to cos pi by 2 by sin pi by 2. Cos pi by 2 value is 0, sin pi by 2 is 1, which is equal to 0. So for at this point the function is 0, that is minus pi by 2, minus 3 pi by 2, and here 3 pi by 2. At these points the function is, cot x function is 0. So now we will see here, when x tends to 0, so here we see when x tends to 0, cot x tends to infinity. We can say that cot x tends to infinity. So when x tends to 0, cot x tends to infinity. So the graph will be like this, and here it will go to downward direction. Okay, so when x tends to pi, this graph will change tends to minus infinity. So the same argument here also, the value cot x can take values from minus infinity to plus infinity. Therefore the range is set of all real numbers. So the same way here also. At this point also it will be like this. It should not touch this dotted line. It will go very close to it. And here also. So this is the graph of cot x. So we have seen the domain, range and graph of cot x. Now we will move on to the next function. Now fifth function, f of x is equal to cosec x. So you know how to define this function. This is equal to 1 by sin x, and here the denominator is sin x. So sin x should not be 0. So we have to write the condition x should not be integral multiple of pi. So we can write the domain. From this we can easily write the domain. X can take all the values of real number except this integral values of pi. X belongs to R and x does not belongs to n pi, where n belongs to z. Now we will see what is the range of this function. So here you listen, you know that the range of sin x is minus 1 and plus 1. That is, sin x lies between minus 1 and plus 1. Now I am going to take reciprocal for this inequality. So what I am getting is minus 1 by minus 1. I can write this as 1 by minus 1. When you take reciprocal, the inequality sign will change. So less than will become greater than. Here I will get 1 by sin x, which is greater than or equal to 1 by 1. So I will simplify this. Minus 1 greater than or equal to 1 by sin x is cosec x greater than or equal to 1. Now we will split this. Actually here we have two parts. First part you see minus 1 greater than or equal to cosec x, or I can write this as cosec x less than or equal to minus 1. So what is the value cosec x can choose here? Imagine the number line. This is plus infinity, minus infinity. Here we have minus 1. So cosec x is less than or equal to minus 1 means this is the interval actually. Okay. So how will you denote this interval? Minus infinity to minus 1. So open closed minus infinity to minus 1. Now we will see the second condition. Cosec x is greater than or equal to 1. That is, here we will have 1. So cosec x can take values from 1 to, it can be greater than 1. That is from 1 to infinity. So this interval also will come here. That is, this interval we will denote as closed 1 infinity, closed open 1 to infinity. So this region, actually the union of these two interval will be the range of cosec x. Okay, so we can write cosec x is equal to open minus infinity minus 1 closed union closed interval 1 to infinity. Okay, so this two intervals union will be the range of cosec x, or we can write this range in another way also. In the set of real numbers, if you remove this portion, what is this portion? We can call this as open interval minus 1 plus 1. So from the set of real number, if you remove this interval, that will give you the range of cosec x. Okay. Now we are going to see the graph of cosec x. So we will draw graph x dash, y dash. Here we have 0, pi by 2, pi, 3 pi by 2, 2 pi. Here we will have negative angle minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Now you see here for integral multiple of pi, the function is not defined. That is at angle pi and 2 pi. and here minus pi and minus 2 pi, the function is not defined. Now we will see when x is equal, for other angles we will see what is the function. When x is equal to 0, cosec 0 is equal to 1 by sin 0. Sin 0 is 0, so 1 by 0 is equal to infinity. So when x tends to 0, cosec x tends to infinity. Now we will see when x is equal to pi by 2. So when x is equal to pi by 2, so cosec pi by 2 is equal to 1 by sin pi by 2. That is sin pi by 2 value is 1. That is 1 by 1 which is equal to 1. So at pi by 2, at this angle pi by 2, the value of cosec x is 1. So this is 1 and this is minus 1. Okay, so now we will start from here. For when it moves towards 0, that is when x tends to 0, cosec x tends to infinity. So we will get the graph like this. Okay, from it will start from 1, the point 1, and similarly here in the other portion we will get like this. Okay, now we will see at the 3 pi by 2. So when x is equal to, when x is equal to 3 pi by 2, that is cosec 3 pi by 2 is equal to 1 by sin 3 pi by 2, that is 1 by minus 1 equal to minus 1. So at this point the answer is, the value is minus 1. So here the graph for the other angle it will go like this. Okay, so here you will get like this, again here it is like this, that minus pi by 2. So we will see minus pi by 2 when x is equal to minus pi by 2. So cosec minus pi by 2 is equal to 1 by sin minus pi by 2, that is 1 by minus 1 which is equal to minus 1. So for at this point the value is minus pi by 2, sorry minus 1, so the graph will be like this. So for the next case, here you will have 1 and you will get the graph like this. So this is the graph of cosec x. Clear? So we got domain, range and graph of cosec x. Now the last function sec x we will see. Now the sixth function sec x. So we can define sec x as 1 by cos x. Okay, so cos x should not be 0, that is x should not be odd multiple of pi by 2. So this condition, so we can write the domain is equal to set of all x such that x belongs to R and x should not be equal to odd multiple of pi by 2 where n belongs to Z. Now the range what we have discussed in the previous case, no, cosec x function, same way only here also. You know that minus 1 cos x lies between minus 1 and plus 1. When you take the reciprocal, you will get this inequality sign will change and you will get minus 1 greater than or equal to, here you will have 1 by cos x. So minus 1 greater than or equal to sec x greater than or equal to 1, the same way you will get the same interval here also, minus 1 plus 1. So this interval, so this from minus infinity to minus 1 and from 1 to infinity. So the union of these two interval will be the range of sec x. Okay, so we can write sec x is equal to, range of sec x is equal to from minus infinity to minus 1 union closed interval 1 to infinity. So this is the range of sec x. Now we will see the graph of sec x. Here x dash 0, pi by 2, pi, 3 pi by 2, 2 pi. Here we will have minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Okay, so here we will draw like this. So y dash, here we will have 1 minus 1. Now you will see here at odd multiple of pi by 2 the function is not defined. So for these points we will draw the arrow mark. So pi by 2, then minus 3 pi by 2, here minus pi by 2, and here minus 3 pi by 2. Now at this point we will see at x is equal to 0. So when x is equal to 0, sec x is equal to 1 by cos 0, which is equal to 1 by 1 is equal to 1. So at this point x is equal to 0, the function is, so I will mark here 1. So the function value is 1. Now when x tends to pi by 2, then sec x value is equal to 1 by cos pi by 2. Pi by 2, cos pi by 2 is 0. So 1 by 0, that means sec x tends to infinity. So you will get the graph like this. Okay, and similarly for minus pi by 2 also you will get the same thing. So you will have a graph like this at this point. Okay, now at this point when x is equal to pi, first we will take pi. When x is equal to pi, sec x is equal to 1 by cos pi value is minus 1, so 1 by minus 1 equal to minus 1. So when x is equal to pi, cos value is minus 1. Again when it tends to 3 pi by 2 or pi by 2, you will get the graph like this. It will go to minus infinity direction, and here also at this point minus pi also it will go like this. So this is the graph of sec x. Okay, so the domain, range and the graph of sec x. So in today's video we have seen the domain, range and graph of all the trigonometric functions, and in the next video we will do sums related to these functions. If you like my channel, you can share and subscribe. Your subscription my motivation. Thank you students.